JavaScript has objects, and we've seen how to create a literal object, and we've seen how we can construct an object using a constructor function and the new keyword, like in the previous video. In some of the most popular programming languages, you create an object using a pattern called a class, or a construct called a class. In other words, you create a class named car, and then you create individual instances of the car class as individual separate objects. Now, furthermore, you can create specialized versions of one class, borrowing all the properties of that parent class in the new child class. So you have an original class, and you say, I want to inherit everything that that original class does in my new class. And then you can extend it by adding properties and methods to it to make it a more specialized version of that original or parent class. So to kind of extend the analogy here, I may have a car class, but I want to create a sports car class that extends the definition of just a normal car, and it adds on things that make it sporty. Same thing with a minivan. It's just like a car. It has some of the basic principles of a car, but a minivan also has like number of passengers and cargo capacity, things that make it unique, a unique type of car. All right. And then I can create instances or objects based on that minivan, or objects based on the sports car. And those objects are both have similarities to a regular car, but they have differences as well. All right, so that's kind of the notion of classes and inheritance. And classes and inheritance are a foundational concept associated with object-oriented programming. Not sure if you've ever heard the term, but it's a pretty big deal among software developers. So you might be asking yourself, well, first of all, does JavaScript have classes? Well, yes and no. I mean, in JavaScript, you have objects, and you can create an object and dynamically add properties and methods to it whenever you want to. But objects are the focus in JavaScript. In languages like C# and Java and C++, you create a class and you add properties and methods to the class up front. And they're static in so much that they cannot be changed. So you can't be adding properties and method declarations to the object at runtime. I mean, you can, but it's not the original intent of object-oriented programming. They can't be changed over the lifetime of any objects that are instances of that class. So here in object-oriented programming, base languages like C# and Java, classes are the focus. JavaScript, objects are the focus. C#, Java, C++, classes are the focus. The latest version of JavaScript does in fact have the concept of a class, but it's a weird little stopgap measure to help people that are trying to make the mental leap from an old language that they might be familiar with, like C# or Java, into the world of JavaScript, to a dynamic object-based programming model. So I talk about JavaScript classes in one of the upcoming lessons, and we'll get to that soon enough. But I guess, okay, so JavaScript kind of supports classes, kind of doesn't support classes. What about inheritance? Well, here again, JavaScript, yes, it kind of supports inheritance, but not really the kind of inheritance from traditional object-oriented programming. So in JavaScript, you have something different called a prototype chain. So let's suppose that you've defined a literal object like our typical car example that we've seen so many times. I won't even paste it to screen. You know what it looks like. It has a make, model, and year property, right? And so you define this literal object like our typical car example. You like the properties and the methods that you've already added to that object, and you would like to use that car object as the basis for a new car object. You'll probably wind up changing some parts of the object's definition, maybe some new values and a few of the properties. You might even add some new properties and methods to that new object. And I'm going to demonstrate a technique that allows you to construct a new object based on an existing object here in just a moment. But when you do that, when you create a new object based on an old object, something special happens in JavaScript. There is a permanent link that's created between those. The new object always knows who it inherited all those properties, its original set of properties from. How did it get created? It always knows kind of the link between it and the prototype that came before it. All right. In other words, the original object serves as a prototype for the new object, and the new object is essentially chained to that prototype from that point on. So in languages like C# and Java and C++, those traditional object-oriented programming languages, you create a class hierarchy where one class inherits from another class. So whenever you create an instance of the child class, there's really nothing that's linking that instance of the child class back to the parent class. So there's nothing linking that child object back to the parent class definition. So here again, the focus is not on the relationship of individual objects that happen to be linked to each other and kind of have a brotherhood, but rather more of a parent-child relationship in traditional object-oriented programming. Again, the relationship between classes is the focus of object-oriented programming, whereas in JavaScript, it's the relationship between objects and how they're chained together. It's a subtle but important distinction between JavaScript and traditional object-oriented programming languages. So some people use the term JavaScript prototypal inheritance. All right, but I've tried to stay away from the term inheritance when talking about JavaScript because it might conjure up traditional object-oriented programming concepts that would mislead you whenever you're considering how it all works in JavaScript. One of my favorite JavaScript authors, Kyle Simpson, called this style of object-based prototypal inheritance, it calls it really objects linking to other objects, or OLOO, O-L-O-O, objects linking to other objects. And I really like that description. And by the way, I'm not sure one way is necessarily better than the other. They're different. There are pros and cons depending on what you're trying to accomplish, the given problem you're trying to solve. So what I do want to do is have a better, thorough understanding of how objects linking to other objects actually works and what are some of the ramifications of that. So that's what we'll do in the rest of this video. So you can see that I have a new file called prototypes.js, and here I'm going to paste in my original car. This looks an awful lot like the car literal that we've been creating, object literal that we've been creating up to this point. Now I told you that there's a way to create a new object based on an existing object. And so let me do that. We're going to say, hey, let our new car equal capital O object dot create and then original car. All right, so at this point, if we do, for example, console.log new car.make, for example. So let's go node prototypes. Okay, so we have this new car, and what it looks like, at least at first glance, it appears as though we have a new object called new car, and the value of the original car has been copied of the make property of the original car has been copied into the make property of the new car. But that's not exactly what's going on here, as we'll talk about here in just a moment. But at this point, I have two objects. I have the original car and I have the new car. And I could do several things at this point with new car. I could change the values of the existing properties that I have on new car. I could add new properties to new car or new methods to the new car, or I could delete the existing properties from new car. All right. But more interestingly, I want to revisit something I said earlier about the relationship between the original car and the new car, that there's a link between the new object and its prototype, its predecessor, the original car. And so if we do something like console.log and we say object.get prototype of, and inside of that method, I'm going to say new car. So tell me who the prototype of this object new car is. And it'll say it's this object right here, where the make is BMW, the model 745 Li, and the year is 2010. All right. So it's pointing to this original car. So let's do this instead. We can actually get a reference to my prototype. Get prototype of, passing in new car. And then I can do console.log my prototype.make. And so you can see here that I'm able to get back to that, to the make property of the original car. Now, there's no way to really prove that because they both seem to have the same values right now, but we're going to push this a little bit further. What happens if I were to add a property to the prototype? In other words, what happens if on original car I were to add a doors property, like a doors count? So if you remember, all I need to do on an object to add a property is just go, hey, I just want a new property called doors. So I do dot doors. And then I'm going to create the value and say, hey, it's 4. Now, let's go console.log new car.doors. All right. And you can see that the new car gets this doors property and it seems to be copying that new property over, but that's really not true. But we definitely see that there's a link between the new object and its prototype, the original car. But how do I know if the property is defined on the new object or on the prototype? Well, here's what we can do. And so this is going to help us to kind of get to the bottom of this relationship right here. We're going to start with the original car and says, do you have your own property? Does this property belong to you? Or are you essentially borrowing it from your predecessor? So first of all, it's true that the original car has its own property called doors. Okay, so console.log new car, do you have your own property called doors? And that's false. All right. So kind of tying this all together and kind of explain what's really going on here. Well, whenever we attempt to get a property or call a method on an object, JavaScript will go through a series of lookups to find the value or the definition of the property or the method in order to call it. So after we created new car, it had none of its own properties. If we asked it for the value of one of its properties, doing something like we did here in line number 9, it would find the prototype that new car links to and see that if it has its make property. So we know that the new car does not have a property that we define on it called make. But what about its prototype? And yes, the prototype, the original car, has a make property and it's set to BMW. Okay. But once we do something like this, new car.make equals Audi. All right. So we are changing the property, or actually we're creating a property on new car and we're setting its value to Audi. At that point, what happens is whenever we come down here and basically call the same, essentially same line of code now in line 11, it's saying, hey, new car, do you have a property called make? And new car says, yes, I do now. I have my own property called make and it's set to the value Audi. All right. So no longer do you have to continue and look at my prototype to find the property and its value. You can look at me and find the property and its value. All right. So JavaScript doesn't need to look at the prototype chain if the property is created and set on the new object that is essentially created from the prototype. So if we ask for a property that's not yet been defined, so here we go, let's go here in line number 12, console.log new car.whatever. All right, now think about this. Whatever property does not exist on new car. Whatever property does not exist on its prototype, the original car. So what happens next? Well, then JavaScript will traverse back and say, hey, original car, what are you linked to? And since we defined original car like this, we're linked back to type object. Actually, it is the built-in native object function. However, the whatever property is not defined on that either. So now what happens? Well, finally, JavaScript will do one final traversal asking the object built-in native object what its prototype is, and by default, it will return the primitive undefined. So when we get to line number 12, in fact, let's go ahead and comment out just about everything else here. I'm going to hit A there, and we'll get rid of all this just so we can kind of see what we're doing here. So at this point, what happens? We get undefined. Why? Because new car doesn't have a whatever property. We look back, and the prototype, original car, doesn't have a whatever property. Its prototype, object, doesn't have a whatever property, and its prototype is undefined, and that gets returned. Okay. That's the end of the chain, so to speak. And that, my friends, is basically how the prototype chain works in JavaScript. You don't have to use this. You probably should know it, although you could probably go your whole career and not really have to ever deal with it. However, this is fundamentally how all your objects work and why you get the undefined type returned when you attempt to access a property value that doesn't exist. So I tried to make this as simple as possible, but this is a post-beginner topic. In fact, I was looking at some tutorials online and I saw that this was actually an advanced topic. But if you kind of understand what we're talking about here, just think about how far you've come in your JavaScript understanding to get to this point where you can kind of understand what's going on. That's impressive. So I would just recommend that you watch this again, you take a look at a few other tutorials online, and you give it some time to sink in, and you'll probably leapfrog over a bunch of people who are trying to learn JavaScript, but not really pushing themselves past the absolute basics. You're doing great. Hang in there. We're making great progress, and we're getting close to the end, relatively close. All right, so we'll see you in the next video. Thanks.